Hello and welcome back to Geometry. Today we will read Lesson 3.1, Parallel Lines and Transversals. Previously, you used angle and line segment relationships to prove theorems. Now we will identify the relationships between two lines or two planes and name angle pairs formed by parallel lines and transversals. Why might this be useful? Take a look at this. An Amy's room creates the illusion that a person standing in the right corner is much larger than a person standing in the left corner. From a front viewing hole, the front and back walls appear parallel when in fact they are slanted. The ceiling and floor appear horizontal, but are actually tilted. So let's look at the relationship between lines and planes. The construction of the Ames room above makes use of intersecting, parallel, and skew lines, as well as intersecting and parallel planes to create an optical illusion. Let's define some terms. Parallel lines are coplanar lines that do not intersect. For example, line JK and line LM are parallel here. We use arrows on the diagram to indicate the lines are parallel. Skew lines are lines that do not intersect and are not coplanar. For example, lines L and M are skew. They will never intersect each other because they're on completely different planes. You can think of them as drawn on two different pieces of paper. Another way to define parallel lines is to note that they're always the same distance apart from each other, whereas skew lines will quickly get farther and farther apart. Parallel planes are planes that do not intersect. For example, planes A and B are parallel. Now, if segments or rays are contained within lines that are parallel or skew, then the segments or rays are parallel or skew. We'll look at some examples identifying parallel and skew relationships in part 2 of the video. Now, please watch out when trying to determine if things are parallel or skew. Just because you don't see the planes doesn't mean they can't be created. So here, FE, that is the segment at the bottom front of the cube, is not skew to segment BC. They are parallel in plane BCF. So imagine a diagonal slice of the cube there would contain both of those segments. Again, check for the distances. If the distance at each end would be measured the same, then they could be set coplanar and made parallel, or shown to be parallel. Now, let's talk transversal angle pair relationships. A line that intersects two or more coplanar lines at two different points is called transversal. So again, two or more lines intersected at two different points. In the diagram below, line T is a transversal of lines Q and R. So here is line T, here is Q, here is R. One line intersects two others. Notice that line T forms a total of 8 angles with lines Q and R. These angles and specific pairings of these angles are given special names. We're going to encounter these so frequently that we would like to be able to refer to these angles and their pairs quickly and easily. So first of all, we have 4 interior angles lie in the region between lines Q and R. So note the coloring here. Everything between the two lines is the interior. Everything on the outside of those two lines would be the exterior. So the interior includes angles 3, 4, 5, and 6. 4 exterior angles lie in the two regions that are not between lines Q and R. That would be angles 1, 2, 7, and 8 as numbered here. Consecutive interior angles are interior angles that lie on the same side of transversal T. So these are sometimes called same side interior angles. So that gives us one pair of 4 and 5 here, and another pair of 3 and 6. So you have to pick two that are interior and that you could go from one to the other without having to cross the line. Alternate interior angles are non-adjacent interior angles that lie on opposite sides of transversal T. Angles 3 and 5 here and here. Notice I have to go across the interior and across the line. And angles 4 and 6. If you were to trace out the lines, or at least the segments connecting these angles, you'll form a sort of a letter Z. It's a bit misshapen here because of the extreme angle between lines Q and R. But it is nonetheless some sort of zigzag type shape. So there's angles 3 and 5 outlined there, forming the zigzag alternate interior angles. Alternate exterior, similar, non-adjacent exterior angles on opposite sides of transversal T. So non-adjacent, that means angle 1, angle 2 is adjacent, so not that one. 8 is on the same side, so not that one. So angles 1 and 7 are alternate exterior angles, and angle 2 and angle 8. And finally, corresponding angles lie on the same side of the transversal T and on the same side of lines Q and R. They are in the corresponding corner of the intersection. So angles 1 and 5 are corresponding. They're both in the upper left corner, upper left corner. Similarly, 2 and 6 are both the upper right. 3 and 7 are the bottom right corners. And 4 and 8 are corresponding angles. They are both in the bottom left corner of their respective intersections. Again, we will come back and practice the examples in part 2. Now, when more than one line can be considered a transversal, first identify the transversal for a given angle pair by locating the line that connects the vertices of the angles. That's how you know which one is the relative transversal to the pair. It connects the vertices. Now remember, a transversal must intersect two lines at two different points. So here, line C could not be considered transversal because it only intersects at one point. And that takes us to the end, ready for checking your understanding. So long, farewell. Enjoy the rest of your day.